Welcome to the H series of webinars. This series is aimed at new and aspiring sheep producers to give them a step up into the Queensland sheep industry. This hunger webinar is part 9 of the series and covers how the rumen works, meeting feed requirements, and monitoring the condition score of your animals. This webinar was delivered by Geoff Duddy from Sheep Solutions on the 7th of July 2021. This is clip 3 of 6 and covers feed intakes, digestion basics, and the role and function of the 4 different compartments of the stomach.
Rough rules of thumb: to maintain a sheep, normally we talk around about 1.5 to 2% of their live weight is what they need to eat a day on a dry matter base. I'll explain that in a second. For production, for example, if you've got lambs in a feedlot situation where you might be 70 to 80% grain and 10-20% roughage, I normally work on around high 3s to 4% of their live weight is what they need a day. But it really does depend on their age, the weight of the animal, feed type, wastes, and that sort of thing. And again, any environmental influences like cold, wet conditions are going to increase requirements. So we've got to take into account stages of production. All feeds are compared on a dry matter base. And I'll just give you an example with that. If we look here on the right-hand side, if we're in a full-blown drought, we have a 50 kilogram animal, so let's say a wether, that is the amount of feed or barley. From that photo there, you can see barley, 90% dry matter, 12 megajoules of energy, and that's 3/4 of a kilo of grain. That's what they need a day to maintain condition. Alternatively, if they're grazing, and an example I've got on the left-hand side here is lucerne, 33% dry matter, 10 megajoules of energy, that's 1,250 grams. They actually need twice that amount compared to that 750 grams of barley to maintain condition. And this is one of our problems we have, particularly during winter, when we have a lot of moisture in our feed. For example, if you are actually grazing cereal crops, we may be looking at 70 to 80% moisture. And so the animal's got to get that twice that amount through the stomach to actually be able to harvest their requirements. Okay, just on the stomach and how that all works. The rumen doesn't have 4 stomachs. It has basically one stomach with 4 compartments. Rumen and the reticulum are pretty well the same thing. They have similar functions. They're just separated by a bit of muscular folded tissue. The omasum, the abomasum, and the small intestine. Each has a specific physical and or chemical role during digestion. So if we look at it, we have what we call the forestomach. We have the reticulum, rumen, omasum, and we have what they call the true stomach or the abomasum. So basically, food is swallowed with minimal chewing. Give you an example, if they're on a high grain diet, they may only chew 30% of their ration. The rest goes in whole. That chewing stimulates the production of saliva, and depending on the dry matter levels of the feed in particular, sheep will produce anywhere between 6 to 16 litres of saliva a day. Now, saliva is important because it contains things like sodium, potassium, phosphate, bicarbonate, which I'll talk about in a sec, and urea. Also has enzymes which will help break down fat and starch. So to my mind, we want to keep that animal chewing, cud chewing, and producing that saliva for a number of reasons. It helps with chewing and swallowing, recycling of nitrogen in the system, buffering pH levels in the rumen, and trying to maintain rumen pH around about a neutral, around about 7, it's between 6.2, 6.8. Under normal grazing conditions, this is the best in terms of effective digestion and ensuring a well-balanced, efficient bug population. And that's what we aim for. We want to have a healthy rumen. To do that, we need to make sure that we are balancing up energy intakes, protein intake and production, and also fibre in particular. What they do is basically form what's called a feed bolus, and that is regurgitated and rechewed. And while they're doing that, they're breaking down that material to finer particles and producing more and more saliva. So it's in the rumen, back and forth through the esophagus where it's chewed up. And sheep can have up to 30 to 40,000 jaw movements a day, right? And while they're doing that, grazing and chewing the cud, they're producing that saliva. Solids move into the rumen, which is basically a fermentation vat. The rumen will hold about 7 litres of food and fluid in sheep. It contains billions of bacteria, protozoa and fungi, which help to actually ferment and or break down and utilise the feed. And importantly, it contracts between 1 to 3 times a minute. Now that's important for mixing all the contents within the rumen. What happens is that we have a fibre mat form at the top of the fluid in the rumen. Long particles or new feed coming in land on that fibre mat. They mix in slowly. The rumen fermentation is stabilised. All the finer particles, their breakdown is actually slowed down, so we don't have that massive production of acid that can cause acidosis, and it will reduce that risk of issues with the gut, and importantly allows the bugs to break down the feed. So as I mentioned, what we're actually doing is feeding the bugs in the rumen. And what the role these bugs have, they digest cellulose, sugar and starch or carbohydrates. They produce byproducts, things like volatile fatty acids, which we'll talk briefly about, ammonia, carbon dioxide and methane. They synthesize amino acids from non-protein nitrogen. Non-protein nitrogen, to give you an example, is something like urea. They synthesize vitamin Bs and K. B12 in particular is an important one for energy production. And importantly, they're a major protein source. A lot of the bugs in the gut that are washed down through into the small intestine are actually digested and used as protein.